Hey everybody, welcome back. Hope everyone had a good Thanksgiving. Today's video, we're going to move on to lesson 3.4. This starts the second half of chapter 3. And today's topic is graphing linear equations in standard form. Now, there's different types of ways to write equations. This one is just called standard form. In my opinion, this is not the most common way, and it's not the way that you'll see a lot, but it's not too difficult, so I don't think we'll have too many issues with it today. Here's what standard form looks like. Standard form is always going to have a certain variable, usually an x and a y. It's usually going to have some number in front of the x for the coefficient and then some number in front of the y for the coefficient. And it's always going to equal something at the end. Now, 99% of the time, you are not going to see decimals and you're not going to see fractions. If you look at all these examples here, you don't see a decimal or fraction on any of them. Now, that's not a 100% requirement, but most of the time you will not have decimals, you will not have fractions. And then what you really want to take out of this is, in standard form, the x and the y are on the same side of the equal sign, right? The x and the y are on the left-hand side, and then the equal sign has just a regular constant, a regular number on the right-hand side. That is the big structural thing with standard form. The x and the y are both on the left-hand side of the equal sign. Because later on in this chapter, we're going to see a different form where the x and the y are on opposite sides. And so here, the x and the y are on the same side. I would say most of the time there are no decimals and no fractions for the coefficients, right? 2, 1, there's a 1, 3, 3, negative 4, 12. Doesn't matter. Usually not going to have decimals and fractions. You can. It's not the biggest crime in the world. But most of the time it doesn't have decimals or fractions. The x and the y are on the same side of the equal sign. Every once in a while, you won't have one of the variables. It might just be the x or it might just be the y. Right? That would be the same thing as saying like, 1x plus 0y equals 5. Like these are basically the same thing, but no one's ever going to write it like this, like I wrote in orange. People are just going to put x equals 5, y equals whatever. And so every once in a while, you'll just have one variable. That is okay. This is still standard form. It's kind of a weird way of looking at it, but it is still standard form. So what I actually want to look at first today is how do we graph equations that look like this? And then we'll move on to the second part of the video. How do we graph equations that look like this? It's not the hardest thing in the world, but it is just a little bit tricky. The ones that look like this, where you just have one variable, x equals, y equals, just one variable. You don't see both. These are always going to be straight lines. It'll either be straight vertical or straight horizontal, depending on if it's x or y that you have as your variable. The ones over here where you have x and y, those will always be diagonal lines. Always. So if there's only one variable, it's going to be straight up and down or straight across. If it has x and y in the equation, it will always be diagonal. All right, let's start with the first one. Let's actually go over here, grab this board. This first board, how do we graph it when x equals something or y equals something? I have 4 different examples. I just put them in the corner so I could space them out. I'm not like trying to separate it into quadrants or anything. It just kind of looks like that. So how do we graph it when you have x equals a certain number? I just put in for number because I didn't know whether to put 5 or whatever. How do you graph it when y equals something, right? So let's start with this one. Let's say this is our problem right here. We need to graph y equals 2. Y equals 2. Now, I could go on the y-axis. I mean, we know we have an x-axis and a y-axis. I could go to y equals 2 like that, but that's not good enough, right? It isn't just a point. This isn't like a number line. This is all of the points in the history of the world where y equals 2. Here's how I like to do it. Think about it. Normally, when we pick an x and y table, I just have you all pick whatever numbers you want for the x category. Look what the equation says. The equation says y equals 2. So I can pick whatever. Well, you know what? I'm just going to fill this in. Look, y has to equal 2 because that's what the equation says. Y equals 2. So look, I just put 2, 2, 2, 2. And then you pick whatever number you want over here. You could pick 0, you could pick 1, you could pick 2, you could pick 3, you could pick 5, you could pick negative 4, you pick whatever you want, right? The equation says y equals 2, and so look at all these points. Every single point that I listed here has 2 as the y coordinate, right? The point 0, 2, the point 1, 2, the point 2, 2, the point 3, 2, right? All of these points, I'm not going to write it like this on all of them, but I just want to show you, for example, this is the point. All of these points that I graphed, look, the y coordinate is 2 in every single one of them. Look what type of line we're making here, guys. Y equals 2 is a Whoa. Horizontal line, straight across. It should not have that little curve in it. Horizontal line. Back in the olden days, my teacher would make me write the equation on the line, but you all obviously won't be doing that because you'll be doing it on a computer. But y equals 2. Perfect, right? The y coordinate is always 2 on all of those points. Down here, I'll do this one in a different color. Let's pick blue for this one. Y equals -3. Same idea. If you want to make a chart for yourself, you can. You don't have to. I know that the problem says y equals -3, so my y has to be -3 every single time. And then for x, I can pick whatever numbers I want. I'm going to pick 0, 1, 2, and 3 because those are easy. 0, -3, 1, -3, 2, -3, 3, -3. Look at this. Another completely horizontal line, y equals -3. So whenever you have y equals 2, y equals -3, y equals 1, y equals 0, y equals anything, it's always going to be a horizontal line straight across. This is a line that has 0 slope. It is completely flat. I'm not going uphill. I'm not going downhill. I could walk across this. I could run across this. I would not be changing elevation at all. That's whenever it is y equals. Now let's switch it up. I'll do one in orange here. What about when it says x equals 5? Okay, so if I'm doing my little x and y table, it says x equals 5. So for the x's, I have to put 5 because that's what the problem says, x equals 5. For the y's, I can pick whatever numbers I want. Usually we pick whatever we want for the x's, but on this, I'm just going to pick whatever I want for the y's. I'm going to pick 0, 1, 2, and 3 over here. All right? When it's x equals something, you can probably guess what this one's going to look like, right? 5, 0, 1, 2, 3, 4, 5. That's right here. 5, 1, 5, 1. 5, the point 5, 2. 5 to the right and 2 up. It's, oops, kind of overlapping here with my other one. Let me kind of get that out of the way. The point 5, 3 is right here. Look what type of line we have on these. Look at this. X equals 5. So now we have, instead of a horizontal line, now we have a vertical line. Anytime you have x equals something, that's what you're going to see. Because, right, isn't this 5 on the x-axis? This is 5 on the x-axis. Every single point along this line, even if I go all the way up here and pick a point way up here, look what I would have. This would be like maybe the point 5, 10, 5 to the right and 10 up. Look, the x-coordinate is 5. If I went all the way down here to the bottom and I picked this one, this would be 5, -6, right? 5 to the right and then 6 down. Look, the x-coordinate is still 5. And so this is a line that goes straight up and down. Vertical line, you don't have to draw it as tall as or as all the way to the bottom of your screen though, or of your page. And then let's do one more. If it gives you a decimal, don't have a panic. It's still okay. X equals -1.5. I don't know if you can see that very well. The green doesn't maybe show up. X equals -1.5. So if I want to do a table for myself, look what the problem says. The problem tells you what to do. X equals -1.5. So underneath the X, I need to just put -1.5. Really only need to do 3. I've been doing 4, but you just need to do 3. And then for the Y, pick any number you want. Maybe you pick 1, 2, 3, right? -5 and then 1. This is the point. -5, -1.5, comma 1. That's like right here. -1.5 and 2. -1.5 and 3. Look at this one, guys. It's right in between 1 and 2. Look at that. X equals -1.5. Vertical line, straight up and down. These last two that I just did, when it's x equals something, you have vertical lines. These are not functions, right? They fail the vertical line test because a vertical line touches it in multiple points. These are not functions, but they are vertical lines, and that is how you have the difference, right? If it's x equals, it's going to be a vertical line. These have an undefined slope. We'll eventually talk about that. The ones that say y equals are going to be horizontal lines. I erased the other one, but it was right here. Horizontal. When it's y equals, you're going to have horizontal, a slope of 0. When it's x equals, it's going to be vertical line. The slope is actually undefined for that. Okay, I'm at 10 minutes. I'm going to go a little bit quicker here for the last batch of questions. What do we do whenever it is both variables in the question, right? We're going to do something that we call finding the intercepts. Do y'all know what an intercept is? The intercept is where the line touches the y-axis. Like this orange one right here has an intercept, an x-intercept of 5. It touched the x-axis at 5. This purple one has an x-intercept of -1.5, right? This one has a y-intercept because it doesn't touch the x-axis. This one has a y-intercept right here at -3. So how do you find the intercepts? Easy. We're going to plug in 0 for the place of whichever variable that it is that you are not solving for. Let me say that again. If you want to find the x-intercept, you substitute 0 in for y. To find the x-intercept, put 0 in for y. That makes sense because, look, any point on the x-axis, if I just pick any point on the x-axis, like I pick this point right here, look what the y-coordinate is. It's 0. If I pick this point right here, that is the point 1, 0. Look at the y-coordinate. It's 0. If I pick this point way out here, -5, 0. Look, the y-coordinate is always 0. If you have a point on the x-axis, the y-coordinate is always 0. So to find the x-intercept, put 0 in for y. And then the opposite also works. To find the y-intercept, put 0 in for x. So it's just basically a little substitution question. You're going to do 2 little miniature equations. Shouldn't cause you too much panic. Let's do the first one. To find the x-intercept, put 0 in for y. Okay, here's my equation. I'm going to plug 0 in for the y. So if I put 0 in here for the y, I would have 4 times 0, which obviously, some of you all can do this in your head, right? 4 times 0 is obviously 0. And so I could write it like this, 3x plus 0 equals 12. But let's be real. A lot of you can probably just erase that and just say, hey, wait a second. This is the same thing as just 3x equals 12. I mean, plus 0 is really kind of pointless. And so some people can just like cover it up here. They'll just cover it up with their finger and they'll say, okay, 3 times something equals 12. Easy. I know that answer. The answer is 4, right? Divide by 3 on both sides. So x equals 4. That means this touches the x-axis. This has a x-intercept of 4. So I'm going to go to 4 on the x-axis. Boom. I put a point right there. Now we'll do it again. Now we'll do the y-intercept. So I did this. This had an answer of 4. Now I'm going to do step 2. To find the y-intercept, put 0 in for the x. Okay, so to find the y-intercept, I'm going to put 0 in for the x. So right here, this is going to equal 0. Let me do it off to the side. If I put 0 right there for the x, and then just copy the rest of it down, equals 12. Look what I have. I have 0 plus 4y equals 12. That is basically the same thing as just saying 4y equals 12, right? No one needs to have plus 0. That doesn't do any good. 4 times something equals 12. We all know that in our head. That's obviously 3. And so this one has a y-intercept of 3. The x-intercept is 4. I made it right there. The y-intercept, that's on the y-axis, is 3, positive 3. I'm going to go right here. And guess what you do with those 2 dots? You connect them. Just like this. Now, if this was me back in the 1990s in my algebra class, my teacher would make me write it on there. You all obviously won't have to do that because you're doing it on a computer. But there it is. The x-intercept was 4. The y-intercept was 3. I showed you the long way. This is the long way. A lot of you can probably, if you get good enough at this, you can just like cover this up with your finger and say what? 3 times something equals 12. Okay, I know that in my head. 3 times 4 equals 12. And then cover up the other one. And you have positive 4y plus 4y equals 12, right? Positive 4 times what number equals 12? That's 3. And so that's why the y equals 3. Boom. That's a fast way to do it if you don't want to write it all out. Let me do 2 more just to show you that it works. And then we'll get out of here. This video is going to get close to 20 minutes. I apologize. Okay, here's another one. I'll try to go a little bit faster. If you feel like you're already confident, you don't have to watch these. Find the x-intercept. To find the x-intercept, I'm going to put 0 in for the y. So I'm going to put 0 in right here for the y. I could just cover it up with my finger and say negative 4x equals negative 16. If I'm not that confident, I'm going to put 0 in for the y. To find the x-intercept, put 0 in for y. So I'm going to put a 0 right here in for the y, substitute it in there, and then just work it out. 0 times anything is 0, and so I have negative 4x plus 0 equals negative 16. Adding 0 is really not important, right? It doesn't do me any good. So I have negative 4x equals negative 16. Negative 4 times something equals negative 16. We should all know that, right? The x-intercept is 4. So I'm going to go on the x-axis. I'm going to go to 4. Boom. Put my point. That's half of my answer. Now let's do step 2. So my x-intercept was right here, 4. To find the y-intercept second, I'm going to put 0 in for x. I'm going to put 0 in for the other variable. So I'm going to put 0 up here for the x. I'm going to put 0 in the spot of the x, right? Instead of the x, I have a 0. I'm just going to copy the rest of it down. If you are really good, you can just kind of cover this up with your hand and say, okay, what? I have 8 times y equals negative 16. What number times 8 would equal negative 16, right? Negative 4 times 0 is 0. Here it is down here. This is the long way. You don't really need to put plus 0. That doesn't do you any good. 8 times something equals negative 16. We all know that in our head. That's negative 2. Y equals negative 2. My y-intercept is negative 2. So on the y-axis, I'm going to find negative 2, 2 places below the origin. Boom. I have it. And then I'm going to connect those 2 points. Diagonal line. Perfect. If I was back in the 1990s in my Algebra 1 class, I would have to write the equation on the line. You don't necessarily have to do that in this class. Easy, right? Last one. I'm going to keep this under 17 minutes or 18 minutes, I hope. Every once in a while, they'll get a little bit tricky because they'll just give you negative x or negative y or positive x or positive y. Remember, there's no number on there. It's an imaginary 1 for your coefficient. So this is like negative 1x plus 2y equals 7. So to find the x-intercept, put 0 in for the y. I'm going to plug 0 in for the y, or you can just cover it up with your fingers, right? You can just cover that up and maybe try to solve it. But if you're not good at that, put 0 to find the x-intercept, put 0 in for the y. So instead of the y, I'm going to put 2 times 0, substitute 0 in the spot of the y, and look what you get. You get negative, or 2 times 0, which is 0. So you have negative 1x plus 0 equals 7. Plus 0 is really pointless. It doesn't do you any good. You just have negative 1 times something equals 7. We all know that. Divide by negative 1, divide by negative 1. The answer is negative 7. The x-intercept is negative 7 right here. On the x-intercept, of course, I didn't make my graph go far enough to the left. On the x-intercept, I need to go out to negative 7, which I didn't mark that because I was only going to 5 there. So let me go all the way out to negative 7. I'm going to put a dot way out here. Kind of had to extend my graph a little. That's okay, though. Now let's do the y-intercept. To find the y-intercept, I'm going to put, put 0 in for the x. So in this equation, plug 0 in for the x. I'm going to substitute this equation. I'm going to put a 0 in the spot of the x. So I'm going to have negative 1 times 0, and then everything else just is going to get copied down. Anything times 0 is 0. So basically I have 2y equals 7, because 0 plus 2y is kind of pointless. It's the same thing as 2 times y equals 7. This is a decimal. Don't let that bother you. We can handle decimals. Y equals 7 divided by 2. 7 divided by 2 is 3.5, right? 3.5. So my y-intercept is 3.5. On the y-axis, the one that goes up and down, it is at 3.5. 1, 2, 3, and then halfway to 4, right? This is 3. This is 4. I'm going to go halfway between 3 and 4. That's how you handle decimals on these. Don't let them bother you. It's not a big deal. Take your 2 points, connect it with the line. You'll be doing it on the computer. I'm doing it with a marker. And in the 1990s, back before there were cell phones, we had to write it like this. You don't have to write it like that. There you go. Okay, see how all these are diagonal lines? If you have an x and a y, you have a diagonal line. Okay, that is it, guys. I don't want to take too much time. This is almost 19 minutes, and I don't want you to have to watch videos too long. I'm going to put some questions on the Big Ideas Math site. Please, please, please email me if this didn't make sense. You want me to explain it a little bit more in detail, but I think this is going to be one that you'll be okay with. Just substitute x, or substitute 0 in for x, substitute 0 in for y, get your 2 intercepts, and then connect the dots, right? If it doesn't have both variables, if it just has x equals or y equals, if it just has x equals something, it's going to be a vertical line, vertical line. If it just has y equals, it's going to be horizontal, horizontal. This is called standard form, ladies and gentlemen, standard form of an equation. Okay, thank you so much for watching this video. Go check out my questions for you all. Give them a shot. Email me if you have problems, and I will catch you all in another one. See you, everybody.